All right, welcome back, programmers. We are going to do a lot today. This is going to be a bigger asynchronous lesson. Not sure how long it's going to take, hopefully less than an hour and a half. But what we're going to do is we are going to start with this circuit that we had last week. We're going to get rid of the sensors, get rid of the potentiometer and the light dependent resistor, and add two more buttons and add two more lights to it. And we're going to build a game of Simon where it's only going to be a 3-channel Simon. I don't know if you remember Simon. It's a Simon Says game. It was a handheld thing that was really popular in the 80s, where it would give you a sequence of lights and you had to press the buttons that lit up in the correct order, and if you got it wrong, it would tell you and you'd start over. So basically we're going to build a simpler version of that uses 3 buttons and 3 lights, and we're going to control it all with TouchDesigner and do all the programming for the logic in TouchDesigner. So the first thing we need to do is tear down this circuit and make another one. So let's see, I think it'd probably be easiest just to scrap this whole thing. So I'm going to scrap the whole thing. Get rid of that. I'm going to get rid of all of I'm going to get rid of this component, this component, this component, this component, this component, and we'll keep a button, we'll need it. All right, so then you want you're going to use your breadboard. Breadboard, but I want a large breadboard. There it is. Okay. Large breadboard. Although that doesn't have well, I guess it does. Okay. So the large breadboard works just like the smaller breadboard does. But the only thing to realize is that you see this line in the middle, and on your guys' breadboards, there's probably just a gap in the colors. Like there's a blue line, or there's a red line and a blue line, and there's a gap in the middle. That gap is not connected. So this rail, although it says it is in this version, is not connected to this rail over here. At least that's the way it works on my breadboard. Actually, we'll just use this small breadboard, but because this is a little bit unwieldy, and I don't like that it doesn't have the colors on it. So we'll use a small breadboard, but just this will work fine as long as you stick to 1/2 of that large breadboard, and don't stick, because we're going to use these power rails. If you stick components on both sides of both halves of that breadboard, then these power rails are not going to be attached together unless you jumper them together. Okay? And this time we're going to actually use the positive and negative, the positive and ground power and ground rails, just because otherwise we'd have a big tangle of wires. Now this ground rail and this ground rail are not attached together, and this positive rail and this positive rail are not attached together unless you jumper them. So I'm going to go ahead and do that now. So you don't have to do this in Tinkercad. You can do this on your actual Arduino, but I'm going to do it in Tinkercad first, and then I'll build it in real life as quickly as I can. So I'm going to jumper this positive to positive. Make sure you're not jumpering negative to positive, because that will make a short. That's going to be red. And then this one to this one. And that's going to be black. All right, so those are jumpered together. And let's see. I think I'm going to move my Arduino up here and turn it sideways. Yeah. Because the length of my jumpers just makes it easier this way, and I'm not going to be using any more analog pins for this. So just so that I can use short jumpers between here and here. All right, so now I need to hook up the 5 volts, which is going to be a long cable. Let's go this way. 5 volts. Make that red. And we can hook the ground with a short jumper this way. I could have also hooked the ground in here or here. Any place that says GND, you can put a ground in. Okay, so now these power rails are attached to the Arduino, and on both sides. I can pull power from this rail, I can pull power from this rail, I can send ground that way, I can send ground this way. Okay, so now I'm going to put in, we're going to have 3 buttons, and I'm going to bridge the gutter with the buttons. So there's one. Can I copy and paste? Yes. And give yourself a little bit of space in between the buttons. I'm going to skip one hole basically. Okay. And now you see how, and mine work this way too in the real life. My real life buttons work this way too. It has a button and a terminal, then a blank, then a button leg, then a blank. So we can stick LEDs in these other holes because we don't want to share with the button, because then if you power the button in, you're going to be powering your LED. So we can, but we want the LEDs to be as close to the buttons as possible. So let's grab some LEDs. And remember, LEDs go from anode to cathode. So let's see. I usually like to do it the other way around. I'm going to turn it around. But then there's not enough room. Whatever. I guess I'll do it this way. All right. So, oh, and these LEDs don't want to let you spread it out. Well, that's annoying. Okay, fine. I'll just go like this. Whoa. Hello. Let me fix this. Oh, that's terrible. I can't get it back. What? All right, whatever. You move it once and it won't let you put it back nice. This is why we can't have nice things. There we go. And fix your wagon. All right, there we go. All right, got that back. All right, so what I'm going to do, because it won't let me span this LED from this pin to this pin, I just have to be really careful and kind of move it in between like that. Okay, and I'm going to put, and this is a cathode. That's where it's going to go to ground. That's going to go here, and I'll just make this silver gray so that it looks like the leg. And then this one is going to go here. I'll make that gray. Okay, so that is just like, you can just bend your LED that way. You don't have to have jumper wires, right? But then these LEDs, because they won't let me turn it around, they only let me put it the other way, and then I don't have enough room on my diagram. It's having the cathode on this side, but that's okay. So we want this. We want to have the cathode go with a 220 ohm resistor between the cathode and ground. So we're going to stick a 220. Ooh, that's perfect actually. 220 ohm resistor here, and this is not 1 kilo ohm. It is not 1 ohm. It is 220 ohms. The red, brown resistors. All right, so then there's that. Can I just copy all this? Copy, paste. No, it won't let me. All right, whatever. So I'm really careful so that it doesn't snap into place, so I can put it kind of right here. And then I'm going to put that cathode there and the anode here. And let's set those to gray so they just look like the legs. And I'm going to take another 220 ohm resistor and stick it here. And there's one more LED. And I'm going to put that like this. And connect those here like that. Set them to gray. Get out of there. There we go. Set that to gray. And one more 220 ohm resistor from ground to there. Okay, and I want this to be a green LED. We're going to have a red, a green, and a blue LED. So this is going to be a green LED, and this is going to be a blue LED. Okay? Next on the agenda is hooking up these buttons. So this button, one side needs to go to ground, one side needs to go to the digital pin. So let's say this side's going to go to the digital pin and this side will send to ground. So this is connected here, as you recall. And these are actually connected together. Terminal 2B and 2A are connected together. But I'm going to use one side on one part of the button and the other side on the other part of the button, because that'll make it more convenient. So this side's going to go to ground with the short jumper, black. This side's going to go to ground here. This side's going to go to ground here. Make these black. Not red, black. There we go. This one black. Can I rename this? I'm going to call this Simon. All right. Now on this side, I'm going to go to digital pins 2, 3, and 4. So I'll go this way. Make sure you skip pins 0 and 1 because they use those for serial communication. All right, so I'm going to make this, let's say orange. And this one, I'm going to send up here to pin 3. I'll make that one green because it's green, and then I'll make the last one blue. Okay, so those are attached to the buttons. You can see that how that attaches all the way down here. This attaches all the way down here. And then when it goes through the button, it'll go to, what did I just do? Darn it. What just happened? Ugh, I hate that. All right, what's going on with these LEDs? They somehow moved. There we go. I guess I just have to kind of zhuzh them because I moved the breadboard by accident. Yeah, that's better. Okay. So there are, oh, and we haven't hooked up the other side of the LEDs yet. So we're going to have this one be pin 11, this one be pin 12, and this be pin 13. So let's see if I can grab a wire here. Pin 11, and we'll make this I don't know, brown. It's close to red, but looks different than the other ones. And, oh, I have my wire in the wrong place. It needs to be over here. Yeah, it's attaching to that leg. There we go. That's better. All right, so that's going to pin 11. This is going to go to pin 12. I guess I don't want to do green because that one's green. I guess I'll make it like turquoise. Yeah, and then this one is going to go to pin 13. And that'll be purple. Okay, so we have buttons attached to pin 2, 3, and 4. That's this button, and this button. Then we have LEDs attached to pins 11, 12, and 13. And the other side attached to ground, ground, and ground. And then these are attached to ground through 220 ohm resistors. Okay, and that will be all we need on this circuit. We're just going to do 3 channels of Simon. I don't know if I said that already. All right, so let me build it in real life. So let's switch over to my camera. How far behind? Oh, I'm still pretty good right now. Okay, so first we're going to strip all this stuff away from what we had last time. This is what we had last time. I'm going to strip everything off of here. I'm going to carefully set aside my 10K resistor so I don't get it mixed up with my 220 ohm resistors. I can stick it next to my LDR sensor. Those are the ones I use together. Okay. Oh man, these buttons can be hard to get out. I got a little like spudger tool. I got fat fingers. There we go. Ooh, did I break a leg? No, just bent it. All right. So I'm gonna put my Arduino up here just like I did in the Tinkercad. And I got that. All right. So now I want 3 buttons and 3 LEDs. Button, get in there. Ugh, one of my legs got smashed instead of going in. All right, let's try that again. Get in there and don't smash your leg. There we go. There we go. Yes. There's one button. I'm going to give myself a little bit of space. Probably a little bit more than I did on Tinkercad. Yep, there we go. 2 buttons. Three buttons. All right, so now I'm going to do those little jumpers on the power rails here, just like I did in my Tinkercad. So I jump between the 2 power rails like that. I could do it over here also. Make sure you're not going from the power to the ground, or you're going to make it a short. You want it to be from power to power. And then I'm going to have, should I have a short? Was it the same size? Use a shorter cable. From power to power, I think that was the same size anyway. All right, and from ground to ground. Okay. Then we're going to have a red LED. Which is where, there it is. I'm pretty sure the long leg is positive and the short leg is negative. So I'm going to put it in between these 2 pins of the button so that I'm not sharing pins from the button. All right, so that's positive. My negative is over here, and then I'm going to go from my negative to my ground rail with a 220 ohm resistor. See that? Yeah. And there's my other resistors. There they are. They fell on the floor. And so I need a green LED. Yep. And a blue LED. So I'm putting the long leg in the middle, which is going to be what will be driven by the pin. The short leg toward the right-hand side, which will be driven by, which will go to ground with a 220 ohm resistor. So this is going to be a 220 ohm resistor. The 220 ohm resistor just keeps your LED from burning out if you run it too long. It will make it slightly dimmer also, but that's a good thing. It's still going to be plenty bright. And there we go. All right, so those LEDs now have resistors. Okay, we need to hook up the grounds and the buttons, and oh, we need to hook everything to the Arduino. Well, let's do the grounds and the buttons first. All right, so here's a button ground. I'll put it far back because I want to have enough room, as much room as possible to actually push these buttons. You can actually go ahead and if you've got the kit that I have, it comes with plastic button tops, which is nice too. They only give you 2 different colors. It would have been nice to have like a red, a green, and a blue button cap, but they don't have that. So I'll go red, yellow, red. And then red. No, come back. There we go. There we go. Okay, so there's a little jumper there. Folding the wire out of the way. This is going to go from this leg to the ground. Like that. This one is going to go from this leg to the ground. I'll fold it out of the way. Like that. Okay. So we have grounds hooked up. Now we just need to hook up our power pins. All right, so I need, this LED is going to be pin 11. 8, 9, 10, 11. Sometimes it's easiest to just count from where the gap is in the headers, because otherwise it's kind of difficult to see. You see, that looks like it's in 10, but when you look closely, it's all like your angle to the camera or to your eye. So that's why I like to just count sometimes. All right, so there's 11. Let's see here. I don't have a green wire. Guess I'll just use a little red wire. 12 will be the green LED. Okay, and I do have a little blue wire for the blue LED. It's going to be in 13, pin 13. Yeah. All right, I need to hook up the ground to the ground rail here, which is right here on my Arduino. Now the entire board is grounded to the Arduino. I need to hook up my power. What I'm going to do, actually, I did it down here in Tinkercad, but I'm going to do it up here. It doesn't matter. Either way works fine. All right, so now my power is going to be hooked. I got to put that on 5 volts ground. VN ground, ground 5. All right, so now the board has power and ground, and all of my lights are hooked up, and now I just need to hook up the buttons. So I need 3 wires for the buttons. 1, 2, and 3. Okay, here we go. So let's see. I'm going to use this side. This is the first. Wait, I'm going to use a blue for that. I'll use an orange for that. This one is going to go into pin 2, 0, 1, 2. This white one for the yellow. So this is the button that's in this row here, and I'm going to put it right up at the edge so that the wire is further away from it. So I have room to push the button. That's going to go into pin 2, or sorry, pin 3. So I'm using pins 2, 3, and 4. And then this is going to be in pin 4. Oh, I can't even get my finger in here. There we go. That'll be in pin 4. All right, now that I have this, I'm going to kind of fold these wires out of the way so that the lights are exposed and the buttons are exposed, so you can easily hit those. Oh, I cut my finger somehow. And that's the wiring of the Arduino for the. That's all we'll need for this Simon game. Okay. Next thing is to do the coding. So your homework, which I gave you kind of at the end of class, I did it really quick. This is what we ended up with. But it's also your homework to do 3 LEDs, 3 buttons, the LDR, and the pot, right? We're going to, so let's save this as. So this is what you should have had by your homework, and you should have had it working in Arduino in TouchDesigner. Yeah. And so what this does, as you can see, it's you're defining these buttons, these things, and then you're printing out the button states here. Okay? I'm going to start with this and edit it. So I'm going to make file, save as, and I'm going to call this week 12 ASO for asynchronous lesson. I already have one, so I just called it class. All right, cool. So first thing, let's strip out some stuff that we don't need. We don't need pot pin and we don't need LDR pin anymore. We got rid of those. Okay, we're going to keep using those. We don't need these anymore, LDR value and pot value, because we got rid of those. And actually, we're going to change how we read the button so that it gives us zeros and ones instead of having to flip it over in touch. So let's set the initial button state to 0. Okay, that's right, button pin. So this is LED pins 11, 12, and 13. That's what we had. We had button pins 2, 3, and 4. These are kind of backwards. Let me just because I'm nitpicky, I want to put them this way. 11. Instead of going 13, 12, and 11. It doesn't matter, but like it just makes it easier to read. Okay, so LED pins 1, 2, and 3 is 11, 12, and 13. Button pin 1, 2, and 3 is 2, 3, and 4 because you have to skip 0 and 1. Button state 0. Oh, let's change this to button state 1. Or we could say button 1 state, but it's easier to type it this way. 2, 3. All right, so button state 1, button state 2, button state 3. Those are all equal to 0. We set up our pin modes. Yep, we set up our pin modes for input pull-up. That's right, still. We can leave that there like that. We are not going to do any more analog reading. This is where we can automatically flip the value of the button, because by default, when you do the input pull-up, it's going to be high, and when you push it, it'll go low, so it's going to be a 1, and when you push it, it'll turn to a 0. But we can flip that value by just putting an exclamation point before the digital read, which basically says the opposite of the digital read. Button state equals the opposite of the digital read of button pin 1, button pin 2, or button pin 3. Just makes it one character here saves us from having to do a math object in TouchDesigner. All right, so we're going to get rid of the LDR and the pot value serial prints and their spaces because we don't need them. We have button state 1, 2, and 3, and a new line and a delay of 10. Let's cut this down to a delay of 5. It worked fine for me with a delay of 5. All right, so that's the first little bit. The next thing we need to do is add some interesting code for, and that's the wiring of the Arduino for the. That's all we'll need for this Simon game. Okay. Next thing is to do the coding. So your homework, which I gave you kind of at the end of class, I did it really quick. This is what we ended up with. But it's also your homework to do 3 LEDs, 3 buttons LDR and the pot, right? We're going to, so let's save this as. So this is what you should have had by your homework, and you should have had it working in Arduino in TouchDesigner. Yeah. And so what this does, as you can see, it's you're defining these buttons, these things, and then you're printing out the button states here. Okay. I'm going to start with this and edit it. So I'm going to make file, save as, and I'm going to call this week 12 ASO for asynchronous lesson. I already have one, so I just called it class. All right, cool. So first thing, let's strip out some stuff that we don't need. We don't need pot pin and we don't need LDR pin anymore. We got rid of those. Okay, we're going to keep using those. We don't need these anymore, LDR value and pot value, because we got rid of those. And actually, we're going to change how we read the button so that it gives us zeros and ones instead of having to flip it over in touch. So let's set the initial button state to 0. Okay, that's right, button pin. So this is LED pins 11, 12, and 13. That's what we had. We had button pins 2, 3, and 4. These are kind of backwards. Let me just because I'm nitpicky, I want to put them this way. 11. Instead of going 13, 12, and 11. It doesn't matter, but like it just makes it easier to read. Okay, so LED pins 1, 2, and 3 is 11, 12, and 13. Button pin 1, 2, and 3 is 2, 3, and 4 because you have to skip 0 and 1. Button state 0. Oh, let's change this to button state 1. Or we could say button 1 state, but it's easier to type it this way. 2, 3. All right, so button state 1, button state 2, button state 3. Those are all equal to 0. We set up our pin modes. Yep, we set up our pin modes for input pull-up. That's right, still. We can leave that there like that. We are not going to do any more analog reading. This is where we can automatically flip the value of the button, because by default, when you do the input pull-up, it's going to be high, and when you push it, it'll go low, so it's going to be a 1, and when you push it, it'll turn to a 0. But we can flip that value by just putting an exclamation point before the digital read, which basically says the opposite of the digital read. Button state equals the opposite of the digital read of button pin 1, button pin 2, or button pin 3. Just makes it one character here saves us from having to do a math object in TouchDesigner. All right, so we're going to get rid of the LDR and the pot value serial prints and their spaces because we don't need them. We have button state 1, 2, and 3, and a new line and a delay of 10. Let's cut this down to a delay of 5. It worked fine for me with a delay of 5. All right, so that's the first little bit. The next thing we need to do is add some interesting code for receiving characters. There's a couple different ways from the TouchDesigner. There's a couple different ways you can do this. The most common way to do it is uses a thing called serial Parse Int. If you've done TouchDesigner before, and it takes a string input of characters that are separated out, or integers usually, that are separated out by spaces or commas, and then it parses it by you tell it what delimiter you're looking for. And it's okay, but the problem is that it's a blocking function. So if something isn't found from the character string when it's expected, the Arduino code will just stop and wait for it until it times out, which can really slow down your patch. And so there's a much better method. There's a much better method of doing this. Let me show you where I found this. So if you do a Google search for Arduino serial input basics updated, Arduino serial input basics updated. This Robin, has posted a very long thread that explains the very best and fastest ways to communicate with your Arduino. And it doesn't use, he talks about why serial Parse Int is not great and why serial data is slow to begin with. Like, it's 960 characters a second at 9600 baud, which is a gap of a millisecond in between characters, but an Arduino can do a lot in a millisecond. So he talks about some ways to receive single characters. We're going to need to do more than single characters because we're controlling 3 different lights that we need to tell when to turn on. So that wouldn't really work for us. We could probably make it work by manipulating, because all we need is bits, and a 3-bit, a single character is 8 bits. So we could potentially, by manipulating what the character is, decode that into up to 8 lights, but it's not worth it. I'd rather just send 3 different integers, even if they are only 1s and 0s, instead of trying to compose a character from a various set of bits. So then he talks about how you can receive several characters. That's closer to what we want, but we actually want binary data instead of characters. These are characters like a string, right? And so there's something here under... Last year I went way into depth on this, and I'm just not going to do it this year because we don't have time, and with me not here to answer your guys' questions, I just feel like you won't understand what I'm talking about. But if you do have questions about this stuff, I do have a video from last year I can point you to, and I can also just, we can meet and talk about it. But we're going to use the code from example 5, receiving and passing several pieces of data. So now that your heads are spinning and you have no idea what the hell I'm talking about, let's just grab this code from... Yeah, so let's grab this code, pretty much all of it. We don't need this example 5 stuff, so we'll grab it from here. Copy that, and let's go back to your Arduino code. And let's see, looking at my notes, the first thing we want to do is, well, let's go ahead and let's just paste this down here, and we'll move some stuff around. Okay, so there's all of our code. All right, the first thing we want to do, let's fix this parse data, which is a little bit different because all we need, we only need integers. We don't need strings, and we don't need floats, right? So we can, let's see here, temp characters, that can stay the same. Instead of being message from actually just grab this line here. Yeah, we don't even need that string copy function. So grab this line here, copy it, replace this line here with what you just copied. So string token index equals string temp cars comma, all that, that's fine. Then we have value from PC equals A2I index. And then down here, also replace this float from PC like that. And instead of saying integer from PC, we need 3 different variables here. So we're going to call this value 1 from PC, value 2 from PC, and value 3 from PC. Value 1 from PC, value 2 from PC, and value 3 from PC. Okay? And let's see, now we need to actually define those variables up at the top, those values. So let's see here. That's before the, yeah. So where, let's see, variables for holding the parse data. Okay, so it's these right here. So we don't need, so let's grab the, cut those there. That's where those, this is where those were defined. We're going to cut them from down here. We're going to put them up at the top before our void setup. And instead of being message from PC, we want value 1 from PC. We can get rid of this. We can get rid of that. We can copy and paste. Paste. This is value 2 from PC. This is value 3 from PC. Okay. Yeah. And we need this new Boolean down at the bottom. Boolean flag, Boolean new data false. Let's grab that, cut that, and put that underneath here. Okay. And we need those numchars stuff. So let's see here. Where is that? Constant byte numchars, character num, all this stuff. Some of this we probably don't even need, but it doesn't matter. We can just put it in anyway, right? Yeah. So I'm going to cut that out, and I'm going to put that, let's see, where do I want to put it? I guess I'll put it underneath, I'll put it before value 1, 2, and 3. Right there. Okay. Woo! All right, let's see here. What else is down here after it's over? All right, so void setup, we don't need this anymore. This is all stuff that we copied from his thing, and we already have a void setup. We don't need another one. We are going to move some of this stuff around, and these are our functions: receive, start, end characters, and parse data that we're just going to leave at the bottom of the page, and we shouldn't have to even edit those. Am I right? I think so. Great. Okay, so now what we're going to do is, in our loop here, the first thing we're going to do before we read our button states and stuff is we're going to get our TouchDesigner input first. All right, and we're going to do that with this function receive with yada yada yada. Receive with start, end, void receive. Wait, we just need to call this function. Sorry, right here, this. Yeah, from this all the way down to new false, all this stuff. Okay? And we're going to paste that in. We have two void loops now because I have his loop. I need to get rid of his old loop. There we go. All right, so let me show you each page of this so you guys can look at it. Here's all of our constants and variables at the top. Then our void setup. Then our loop. And then we have this function, void function called receive with start end characters. This is just what we copied in. We didn't have to change anything. And then in parse data, we did have to replace these lines here so that each one, instead of saying, I don't even remember what it said anymore, but instead, it needs to make sure we change here to create this value 1 from PC, value 2 from PC, value 3 from PC, and they all use this A2I. So make sure you have that. And then we defined those up at the top here. Okay? Great. Now, this should work. Let's go ahead and upload this. Let me verify it. Uh-oh, show parse data not declared in this scope. Right, just get rid of that. We got rid of that function and we don't need to show our parse data. We're just going to get rid of it. Okay. And, oh, you know what we have to do is we probably, okay, no, that's right. All right. Read button states. So, okay, the first thing we do is read this, yeah. Then we're going to, so read the touch input. All right, so this should work. What this isn't going to do is turn on our LEDs yet. We have to add some code. Let's add some code. Let's just go ahead and do that. So the first thing we do, we got our touch input. Next thing we're going to do is actions on input. Second, then we're going to read button states. Then we're going to print values. Okay, so here are actions. So this is third. This is fourth. All right, so here, underneath here, tab over, we need to actually do our digital writes to turn on those LEDs. So digital, whoops, I need to turn off my caps lock. Digital write, and I'm digitally writing LED pin 1, comma, the value that we read from the PC, value 1 from PC, value 1 from PC. So whatever value we send, we write the LED to that value. So if we send a 1 as our first one, it'll turn on that light. If we send a 0, it'll turn off that light. Is that right? Did I get the value 1 from PC? Yeah. All right. Let's just copy this, paste it, and this is LED pin 2, LED pin 3, value 2 from PC, value 3 from PC. So there, that should do it. So the first thing we do, we get our input with this weird code that we downloaded that I tried to explain to you, but it's pretty complicated, but it works. I've tried it. And then we basically, when it grabs those values with this parse data function, it sticks those in value 1 from PC, value 2 from PC, and value 3 from PC. Next thing we do is we actually digital write those values to our LEDs. So we turn on LED pin 1, pin 2, or pin 3 from our values 1s, 2, and 3s from the PC. The next thing we do is we read whether we're pushing a button or not. If we are pushing a button, well, we read those button states, and then we go ahead and send those button states, separated by spaces and a new line character. Then we have a delay of 5 at the end. All right, so let's verify this again. All right, this works. It built. All right, so now let's go ahead and upload it to our Arduino. So I'm going to plug in my Arduino with its USB cable. I got a blue light flashing on the LED, and I plugged it in. Then I need to go to Tools, Port, USB port, USB modem. If you're on Windows, it's probably COM something. And then I upload. All right, it's on the Arduino. And so now, if I go into TouchDesigner, let's just actually close what I have open right now. And here, I'll build this over from scratch. All right, so the first thing we're gonna want is here, I'll do it this way. We'll build this over from scratch. First thing we're gonna want is our serial input, DAT, serial. Set that to 115200. So that's what the Arduino is running at. And I set the port to the Arduino port, USB modem or COM, whatever. And there's my messages. Those are my buttons. And if I push buttons, I get them. Okay? Next thing I'm going to do is send that to a... Oh, I didn't get a picture of this. I'm going to send that to a, what? Select, I believe. And I'm going to select rows by index. I'm going to be just looking at the first row, start index 1, end index 1. So it cuts out that word message. Not 10, I said 1. What's wrong with you? 1, there we go. Next, we're going to send this to I believe, a convert. And split cells that instead of tab, we're going to use a single space. Yep. Okay, I'm back. Yeah, so just had to get the rest of my notes in order. So we're going to build the rest of this thing up to the point where we can control these lights. I'm going to leave the actual Simon game programming for our in-class meeting on Wednesday of next week. Just because otherwise this is going to be like a 2.5 hour video, and I want to leave us something to do. So we have our buttons coming in. There, yep. Next we want to, let's see, I'll send this to a null DAT, just so that I have a nice place to reference this data. And we're going to call this null, we're going to name it buttons in in. There we go. And yeah, what are we going to do with that? We are going to first of all send this to a dat execute. So we, coming off of this, right click on the output and choose dat execute. And that's not right. That's not right. Sorry, just make a dat execute. And then drag this on there like that. Because otherwise you don't want a line going between these or else it'll erase all your text here. You just want it to reference here under the dat that the dat execute is looking at. And we are going to do, we're going to leave it on table change. And what we're going to do is we're going to send these values to 3 different constants. Let's go ahead and make those constants. We'll just put them down here. Constant chops. And we're going to constant, and this is going to be, let's label the channel LED1. And then label this channel LED2, this channel LED3. Because we're going to use this, these are actually coming from the button, so name it button 1, button 2, and button 3. Actually, let's label it button in 1. Because we're gonna put soft buttons here in a second. And those are probably going to be called button 1, button 2, and button 3. So this is button in 1, button in 2, and button in 3. Okay? Button in 1, button in 2, button in 3. All right. So on our dat execute, we are going to set those value zeros on those. So on table change, tab over, op, single quote, button in 1, single quote, close parenthesis, .par.value 0 equals, we need to reference the first value of this table, buttons in table, right? And this thing just tried to execute in the middle because it's getting some glitches. I actually figured out how to change this to a call and response system that we'll do in a little bit that will pretty much eliminate these glitches. But for now, we need to reference this column, which is 0, 0, this cell rather, in buttons in. So we say equals op buttons, whoops, single quote, buttons in, and then you reference a cell. It's like referencing a channel, but you put a comma in between 2 different values, one that refers to. So it's like a cell, a channel. So you're doing like a open square bracket, and then we do the first channel, the row, comma, and then the column. So that's the first item of that. First item of the buttons in table there, and now we can paste this 2 more times and say change, we're going to do buttons in 2 and buttons in 3 equals buttons in 0. So this is 0, 0, we want 0, 1, and 0, 2, right? And now when I push these buttons, you should see those constants lighting up. So it's just like pushing our software button, but we get it we get the same kind of 0 and 1 values that we get from a momentary software button. Right? What's wrong with it now? Invalid syntax. Par value 0. I already fixed that. Maybe if I just, ooh. If I delete it, oh, whoops. All right, it's gone. That was weird. I think that was just a glitch from when it tried to trigger while I was still programming it. Okay, so now we have that. The next thing we want to do is we want to create some soft buttons that do the same thing. We're gonna so that we can see our physical button presses, and we can press a software button and make the lights light up as the same kind of way as we'll also map pressing the physical buttons to lighting the lights up on the board. All right, so let's create a button comp. We're gonna edit this button comp a little bit to change some of the way it looks. First of all, let's change its size here. Under the layout, let's make it, let's make it 100 by 50 because we're going to need a little bit of room. All right, now go inside of it. And the first thing we want to do is we want to change the text here dynamically, so that you can have a thing that'll say off and on, whether it's on or whether it's off. So what we want to do is all this, the background here is this background text top, BG text top is referencing this table for its different properties, such as its background color, its font color, and some other stuff. So we want to add another column to this that we're going to use to reference the text that is actually displayed instead of just displaying the word button. So we're going to, if you make the color table viewer active here, and you right click on the 3 and say add after on that column, you can add another column. And we're going to, on this column, we're going to add, I think you start with off. So click on the top here, this is just a title text. Okay, then the next one, yeah, it's just basically the same as what's here in text in column 0, but we're not going to use the word rollover. So this is off, and I'm going to use all caps. On, and then off again, and on. Okay, and then for this, for the text, we want to actually do, let's see, we want to, here under DAT, for field component, DAT, we want to reference this table. So put here under this first DAT here, field component, and then DAT. This is color, because that's the DAT we're looking at. And then it says, wait a second, what row and color, what row and column do you want? Well, we definitely want the 4th column. So just change this to 4. And then the row itself is going to be dependent on what is coming out of, take a look at this. So so in the color, for example, here, these colors, the way that works is it's looking at this op called I down here, which is an expression op, and it's looking at the state +1, and it's using that to reference a certain table, a certain place in the in this color table, right? So we actually want this string here or you can just type this out. But go back to text, and here on dat row, instead of just putting row 0, we are going to make this an expression, and we're going to paste in that we stole from the color information. But it's basically this if you want to just type it. Op, open parentheses, single quote, I, single quote, close parenthesis, open square bracket, single quote, state. So it's looking at the state channel of this I expression, and it's taking that value plus 1. So right now it's off, and so that means that that is sending a 1 out. And if you look on our table, 0, 1, off, right? If it sends a 2, it'll be on. If it sends a 3, it'll be off, and it sends a 4, it'll be on. So that will dynamically set that text to be whether the button is on or off. Then as far as what text we're going to display, instead of the word, before that rather, instead of the word button, we want this to be like LED 1 space off. So we could do it this way, LED 1 space, like that. And then we'd have to go into each button and change it. But there's an even slicker way to do it. And that's to use its parent name, so that whatever we name the button, it will put that text down in the field. So if I just say here under text, if I open this up and change this to a expression, and instead of saying LED1, I say parent, which is the parent object, which is this container that this is sitting in, that this button is a part of, parent dot open close parenthesis dot name. Then right now this button is called button 1, right? If you look at the address here, button 1 is the address, right? So that's what its name is. When we rename that LED, it'll be called LED 1 or something, right? Whoops, let me zoom out. There we go. But we also want a space here. So I'm going to say plus, because this is an expression, I can't just put a space here. It won't do anything, right? So I have to say plus, and then I can put in a single quote, space, single quote. Or I could use double quote, space, double quote. I think either one will work with Python. Now it will say the name of it plus just an empty space, and then that'll work. Is there anything else I want to do? Oh, then also you can see the channel out here. The channel name is called V1. We want that also to be like LED1, and we want that also to be controlled by the parent name. So here on rename to V1, click on expression. This is the select chop. And put parent open close paren dot name plus single quote space single quote. And now it'll send that out as the channel name. Okay, so it still says button 1, but as soon as we go out of here, this is really cool. And we can change this to LED1, for example. And now it says LED1 off. And if I click on it, it'll say LED1 on. And I click on it, and it says LED1 off. And because we set it up that way, this is even cooler. If I copy and paste it, the next one is automatically called LED2. And if I paste it again, the next one is automatically called LED3. Okay, so when you take the time to set up those expressions in the text of things, then you can make lots of copies, and each one will be individual because they automatically get a different name, right? And we've used the name of it to set the text. Okay, cool. So we are going to, let's see here. We want to merge these values, and we want each one to kind of overwrite the other. So if you, let's see here, let me move these buttons away from each other a little bit. And then put the button in right underneath this one, button 2 right underneath this one, button 3 right underneath this one. And what we're going to do is we're going to override with a chop, an override chop. So whichever one comes in, whichever one is the last one to come in, then that will be what is sent to the Arduino. So if you click the soft button, that'll turn on the light, or if you click the physical button on the Arduino, that will turn on the light. So put the button comp as the first input into the override, and the button in one, what is this? It's a constant as the second input of this override. Okay, then make a new actually just delete it. Make a new override and do this for each of these channels. All right, and now we're going to merge all of these 3 channels together with a merge chop. So make sure that the first one you hook up is the LED 1. The second is LED 2. Third is LED 3. Okay? And then, let's see here. So now you can see if I press these physical buttons, I get LED 1, LED 2, LED 3, right? And I can also, if I set these to viewer active, I can click these and get the same thing. Oops, they're set to toggles. Let's turn that off for now. I mean, it might be nice to have toggles in a little bit, because you can just turn the light on and leave it on. But for now, let's change these to momentary. So take them out of viewer active and then go to their button type and change it to momentary. Because we're going to want them to be momentary for the Simon game. All right, so cool. We got buttons now. Now we need to, where's my notes? Okay, so now coming out of this merge, we are going to send this back to a DAT. We're going to go back. See how most of your communication with serial, just like the serial in is a DAT, our serial out is going to be through this DAT as well. So we need to convert this to a DAT. So right click on the output and go to DAT and choose DAT2. Chop 2 rather. Chop 2. And that'll create a DAT with tables based on the button inputs, as you can see. And the next thing we need is now we need to set it up for that messaging so that the Arduino program recognizes this input. And the way that the receive character function in Arduino worked is it had the values parsed by commas, right? So in between each value there should be a comma so that it can tell where the next value is. So we need to add commas in between it. And we can use a convert DAT for this. And we're going to change this from toTable to toText. And it says right now it's concatenated with a tab. Change that to concatenate with comma. And now you can see you get 3 values separated by a comma. And these also will still get those button inputs, right? And then we need that start character. That start character, yeah, that start character, which was like the less than character, that was in the Arduino code. And we can do that with a dat expression. Where are you, Mr. Expression? Is it an expression? It's an evaluate. Sorry, evaluate dat. Okay, and you put in an expression right here, and the expression is single quote, less than, single quote. That's our start character. Oh, whoops, we need to make sure that this is actually an expression. Single quote, less than, single quote, and then we're saying plus me dot input cell. Capital C on the cell. So then it will be the input cell, which is this right here, 1. And it first puts one of these less than symbols, then it takes its input and puts it after that. Okay? Now, in order to make this work, we have to convert it back into a table after we've done this, just so that we can reference a specific line and column, because that's the way my program works. So we're going to convert it back to a table. And that's fine. We can leave it like that. And now it has see, this just has a row. Now it has a row and a column, even though there's only one column there. Okay. Now, to communicate with our Arduino, we can attach this to a dat execute, but don't do the right click output. It won't work. It'll break it. Just put a dat execute next to it. And we're going to basically run this code anytime this table changes. And every time I'm pushing it, you can see it's changing, right? So on table change, oh, first we have to make we have to point to what dat we're looking at, which is convert 3. Is that what I did? Or did I? Yeah. Okay. Yeah, so you can either type in convert 3, or you can take this and just drag it on top of it till you see that plus symbol. That'll do it for you. Okay, then we're going to add some code in this on table change. And the code we're going to add, this is what's actually going to send things out the serial. And it's op, open parentheses, dot, single quote, serial 1. That's pointing to the serial operator. And then dot send. And then this has an open parentheses with some arguments. And we need to send op convert 3, right? That's the name of it here, op convert 3. Op convert 3, and the address of 0, 0 in brackets, open bracket. So here, let me move the camera over so you guys can see this a little bit easier. So op serial 1 dot send op convert convert 3 address 0, 0, comma, and the other argument that we're going to need is a terminator character. Terminator, I'll be back, equals, and then single quote, and it's that greater than close character, you know. And that was in the Arduino function where we sent that less than symbol to start the message and the greater than symbol to terminate the message. And then close parentheses. And this, I don't think works. There's one other thing we have to do. Well, let me see if this is going to throw an error or not. Okay, so you would think that this would work. So now if I try to push a button, it actually works. I don't need to do that. So now my lights are lighting up when I push the button. Here, let me show you. All right, all of a sudden I got delay in my camera. All right, the lights light up. And if I press this, I also, wait, let me get, how do I get them both on the screen at the same time? I guess if I change the size of TouchDesigner, like this, ugh, here's an empty project I don't need to have open. There we go. Now you can see if I press the soft button, it also lights up with this delay. Let me see if I can reset my camera really quick to get rid of this delay. Yeah, that's a lot better. Okay, so now when I press the soft button, here we go. When I press the soft button, the delay is back. It's because of my screen recording. So actually, just so that you can see this a little better, let's change these back from momentary to toggle. Toggle down. Momentary to toggle down. Momentary to toggle down. And now I can just turn these lights on. There's not that big of a delay in my system. It's only in the camera from this overhead camera. There's a lot of delay there. When I click this, those lights go immediately on or off. All right, so that is mostly what I wanted to do, but I wanted to show one more thing. And that is how we can change this to a call and response system. So right now, our Arduino is just streaming constantly. And I don't know if we'll see it here, but eventually, because it's streaming constantly and because the timing isn't perfect all the time, you'll get a glitch. See that right there, just like glitched? And, you know, depending on what you're doing, that might be fine. You might be able to live with a little bit of a glitch. Like when we were doing the blobby sphere, the glitches would sometimes trigger the thing that changed its color, but nobody really cares, right? Or it might make the noise that we were applying to it all of a sudden get a spike in intensity. That wouldn't matter really either. But with this Simon game, if the glitch causes you to press a button, or the Arduino to think you pressed a button in the wrong order, like it's going to cause you to lose that round when you would have not lost it, and that would be really annoying, right? So we can actually fix this by, instead of just streaming and spamming data to the to TouchDesigner, we can just have TouchDesigner ask for the data on every frame, and which is actually, you'd think that that's doing more communication. It's actually much less, because if you think about it, we're running at 11.5200, which is like 86 milliseconds or something between messages. If you run at 9600, that's 960 messages per second about. So this TouchDesigner is running at, mine currently is running at 40 frames a second, but ideally it'll be running at 60 frames a second. So that's much less communication. So things get a lot more stabler at those speeds. And really, TouchDesigner is not going to do anything in between frames with the information that's coming in. So there's no point in, and it causes errors like this to pop up. And it's like, hey, this is bad data because it got garbled data into it. Right? So what we're going to do is change here. So right now we're only sending data to the Arduino with this code when we get a button pushed. Instead, we're going to send it on every frame to the Arduino, and we're going to change how the Arduino handles that data. So first, let's change the Arduino code. So before you do that, let's turn off the serial so that we can actually re-upload things to our Arduino. Turn the active off on the serial, then go into your Arduino IDE, and this is really, really easy. All right, so here on void loop, we have receive with end markers. If new data equals true, then it does all of this stuff, and that section here is ended with this brace here. We can just move this brace down to the bottom, and then it will only do, it'll do all of this stuff after it does its only other stuff, and it'll only do that when the new data, when there's new data, right? So this turns it into a call and response system. So our TouchDesigner has to send data to it, which it's going to do on every frame, and then it will turn on its LEDs. It will set the button states. It'll read the button. It'll write the LED states to what they should be. And if every single frame, if it was 1 the last frame and it's 1 this frame, then it'll still be on. It just won't change. If this frame it's 0, it'll turn it off, right? It'll read it every single frame, and it will send the data back to TouchDesigner every single frame. That's all I did was take the, let me show you one more time. So I took, where'd it go? There it is. So I took this brace from here, receive with end markers, this end brace, cut it, and stuck it down here after the delay 5 before the end brace for the void loop. That's all you have to do. Save that, upload it to your Arduino. Let me make sure I have my tools, ports right. All right, let's upload this to the Arduino. Okay. Now, instead of this dat execute, don't delete it yet, but put a, instead of dat execute, there's a dat just called execute. And it has a whole different set of conditions for when it executes. And one of them is on frame start. And basically, we want to put this this line here. Oops, so let me grab this line here. I'm cutting it, and I'm going to paste it in here on frame start. So that means every single line it's going to send the contents of convert 3 here to, even if those haven't changed, it'll send it every time on every frame, and the Arduino will only send data back when it gets that message sent by TouchDesigner. It won't send data any other time, which will reduce the number of messages significantly. Now that I've done that, I can get rid of this. I've got my execute here, and I just need to, on my parameters for execute, make sure that I turn on frame start. All right, go ahead and save this. And make sure you save just in case something crashes. All right, so then on serial 1, go ahead and turn it back on, and your Arduino should come back to life. And if you look closely, you'll see now there are 2 lights right here. One is the transmit and one is the receive. Before, that second light would have only lit up when you pushed a button or when you pushed one of the soft buttons in TouchDesigner. Now it's just lighting up on every frame. And it still works the same way as it should, other than my huge video delay. And I can push 2 buttons, I can push all 3 buttons, I can toggle on states here, and that's all we need to do for this asynchronous lesson. And then in class, we'll build the logic for the Simon game, which is basically evaluating whether you press the buttons in the correct combination. If you do, it generates a new combination. And flashes the green light. If you get it wrong, it keeps the same combination and flashes the red light. And then there's a function that plays back the new combination or the old combination. It plays back the new combination if you got it right, plays back the old combination to remind you if you got it wrong, and every time you get it right, it plays that back a little bit faster. All right, cool. So I'll see you on Wednesday. Have a great weekend.